TechTalk.com. We are still continuing with our physics paper 2, and we had looked at something like refractive index of a liquid using real and apparent depths. So I would beg we proceed with another method, that is determination of refractive index of a liquid. And now the method 2 is using apparent and real depths, in bracket optical pin, isn't it? So this is method 2. So we had looked at determining refractive index of a liquid. We looked at using a concave mirror where you put some some liquid in the concave mirror and then make some adjustment. That was method 1. And then method 2 is the apparent and real depths method. And under this apparent and the real method, there are two. There is using traveling microscope. That one we covered it. Okay? Where you make a mark below a cross, below a beaker at the bottom, focus it using a traveling microscope, take readings, and then the liquid whose refractive index is needed and then poured into the beaker, and then adjust the microscope again, and then focus the cross, and then take readings, and then put some object that floats on water, focus that object and get the reading, and then you can get refractive index from the real and the apparent depths. Okay? Which was the C minus A over B minus A. That is using traveling microscope. But now let's use the optical pins. Okay? We are going to look at the method of using the optical pins. A simple sketch would look like this. I can put my pin here. If that is my optical pin. And then if this is my liquid, I'm supposed to know this depth here as maybe say A, and then what will happen is this pin here will appear to be raised to some depths here, yes. This is the image, and then I can use what we are calling a search pin. Okay? And then I can also take this reading here as a B. Okay? And then my observation should be taken from here. This is the person observing. Okay? So I would therefore say This one is a search pin. Search pin. And then this is my object. And then this is my beaker. And then this is my liquid. And then this is the image. Yeah, that is our drawing, how it looks like. So now, using this, how do we determine the refractive index? One, you are required to get an empty beaker and then place your object pin. Okay? Your object pin, the object is a pin. Place an object pin at the bottom of the beaker, and then after placing the object pin at the bottom of the beaker, you now add the liquid whose refractive index is required into the beaker. After adding the liquid, okay, you measure the depths to which the depths of the liquid you have added are noted as a centimeters. And then if you add the liquid in this beaker here, what happens is, as you're seeing from above, you will see this object pin here as if it is raised up. Now, what you do is, you get another pin, you keep moving it outside the beaker. But as you're seeing this one here, as you're seeing the image of this, you will be moving this such that this one locates the level at which, as you're seeing, you keep moving to locate the level at which this one is seen to be raised. So if you have moved this one here outside, and now you have seen that it's really coinciding with the image of this, and then measure the height from the top of the liquid or from the surface of the liquid to where the search pin is, note it as B. And then we shall say that refractive index is given by real over apparent depth. Now, let's describe the procedure now together. We say number one is place, okay? Place an object pin at the bottom of a clean beaker. Okay? Get a pin and put it at the bottom of a clean beaker. And then, in the next step, we said, add the liquid. Add the liquid whose refractive index is required into the beaker, and record the depths of the liquid as a centimeters. Is that okay? So, after putting the pin, add the liquid whose refractive index is required in the beaker, then measure the depths to which you have added the liquid, and then record it as a centimeters. And then after doing that, you now know that the moment the liquid is added here, this pin will be seen raised up. Okay? Now we move a search pin outside to locate the position of the image. And now we say, move a search move such pin up and down outside the beaker to locate the position, move a such pin up and down outside the beaker to locate the position of the image of the object pin. Okay? So you move this up and down to locate the position of the object pin, image of the object pin, by no parallax method. In other words, if you have put the pin like this in a beaker, again don't move it the other side, move it in such a way that it will be in front if the pin is lying like this at the bottom. So don't again, because you will have your beaker circular. So if the pin is like this, don't move here. Move exactly so that it is in a straight line with the other one. So move from here but outside the beaker. Don't again come and move from here when this is like this. Okay? So if it's like this, move like this but outside when this is inside, like this. Not here, not here. Maybe this other side, but they should be in line. No parallax method should happen in that case. So they will be in parallel to one another. That is what you should do. And then to locate the position of the, move a search pin up and down outside the beaker to locate the position of the image of the object pin by no parallax method. And then next is the measure and record the depths B centimeter from the top of the liquid, from the surface of the liquid to the search pin. Okay? You're supposed now to measure the distance from the surface of the liquid up to where the search pin is as a B. Please, even here we should measure, add the liquid in. If we add the liquid with refractive index is required into the beaker, you should measure and record. We are supposed here to say measure and record. Measure and record the depths of the liquid as A. It should be from the surface of the liquid. Okay? It should be measured from the surface of the liquid to the bottom of the beaker. So you should be very careful when you're describing that. So after measuring and recording the depth as B, and then you say, we shall say refractive index. Refractive index of the liquid is given by any L is equaling to A out of B. Okay? Because this one is equivalent to saying that refractive index any is equaling to real depths over apparent depths. Because from here up to here is the actual, or what you're saying, the real depths. So if you measure from the surface up to the bottom, you've gotten your real depths. But now if the pin is observed to be raised up, that means that the depth from here up to where the pin is apparent, or what we're looking at as a relative. Isn't it? It is not the exact height, but it looks like. Therefore, it is an apparent depth. So if now we use this to locate that depth, we can measure from here up to here, and that's our apparent depth. And now we shall say our refractive index is determined from here. And please note that in physics, when they ask you to describe an experiment to determine anything, we can say refractive index is determined from here. You are not supposed to show the working. Why are we determining it from here? So we don't show the theory of why it's the real depth of apparent. Only if it is asked separately that show that in liquid, something like that, the refractive index is determined from real of apparent depths. There you go through describing. But in describing experiment, we only say determine it from here. We don't show the theory of the experiment. Let's now meet in the next description in the coming video.